All right, welcome back to my YouTube channel. So today we are just going to solve some few problems, just about one or two, on the driven oscillation. We have this problem that we're going to attack. We are told to find the resonance frequency, the amplitude, the mechanical impedance, the phase lag, the Q factor, and the power. So we're going to be using the formulas that we just derived in our last class on the driven oscillation. So first of all, we can recall that this is the equation for a driven oscillation. We have mx double dot plus bx dot plus kx equals f naught cos of omega t. So we are given this. So by comparison, m is 2, b is 1.5, and k is 40. As you can see from here, as m, this is b, and this is k. So we can recall that our resonance frequency is given by this expression. So what we just need to do is to substitute our omega naught, which is equal to root k over m, so which gives us omega naught square is equal to k over m. So that's our omega naught square. So our k is 40, our m is 2. So again, our gamma is b over m. So that's our gamma. So if you substitute it, our expression or our final answer for our resonance frequency becomes 4.44 rads per second. Let's move to the amplitude. So this is our formula for our amplitude, if you remember from our last derivation. So what we just need to do is to plug in all our parameters. So we'll do that for m naught, f naught, we'll do that for m, we'll do that for omega naught and omega, and also for gamma. So our final answer should give us 1.2. Again, our mechanical impedance is given by this. We've derived this before. So this is our formula for our mechanical impedance. This is the formula for our mechanical impedance. So we still substitute our expression again for B, substitute for every parameter here, and we'll get our mechanical impedance as 12.09. Then lastly, we have our phase lag. So this is the expression for our phase lag as well. So we're still going to substitute for gamma and omega and others and make theta or phi the subject, which is the phase lag. Our answer is 36.87, which is approximately 37 degrees. We also have to look for our Q factor. So they're very simple expressions, simple formulas we can use. I'll have our power given as this. So this also again is power. So that is written as 1 P equal to 1 all over 2 Zm F naught square times sine of phi. So we can still write our power as this. So any of these two expressions will give us our answer. So let's move on to question 2. So this is the question we're given in question 2, and we're asked to find the value of arrow. So the maximum displacement of the particle occurs when the parameter arrow takes what value. So you should remember that the maximum displacement of the particle occurs when omega is equal to the resonance frequency. So the omega that's supposed to be here, don't forget it was supposed to be sine of omega t minus phi. So this omega here is equal to omega m. So if that is true, it means that pi arrow, look at this, you're supposed to have omega m is equal to square root of this entire expression here. So now our omega m will now be equal to pi arrow. So that's all we just do and make arrow the subject of the formula. Substitute all necessary parameters, and that is the final answer we're going to get for arrow. So see you on the next one for some further examples. Thank you for watching.